For the purposes of the demo here on tuning the PID, I've got a special test version of the program set up so that it drives a servo that actually drives the plunger of a small hypodermic syringe that creates variations in air pressure for the pidostatic sensor. So it's a way of creating an artificial feedback loop around the sensor. So let's start out with some very modest factors, 0.4 for proportional, 0.8 for integral, and a very small factor for derivative. And let's jump back out to our telemetry screen, and you can see that the loop is locked here at 107. Let's turn our P7 knob, and you see the loop responding. The servo, which is being driven by the throttle output, is running the plunger in and out on a small hypodermic syringe to create the ability to close the feedback loop, as I said before. We drop that down, and you can see the loop responding. So this is going to be obviously different for each airplane. Each airplane will have different inertia. Turbines will have different responses, but these modest values are a good place to start. Let's see what happens if we turn the P factor up to 1.5. So we'll save our settings. We'll get back out. We'll bring our throttle up, turn our feedback loop on, drop our throttle down. And you can probably hear the servo going crazy in the background. You can see that we have too much proportional gain, and the loop is actually oscillating back and forth and back and forth. So this is obviously not a good place for us to be. All right, here we are at intermediate setting, proportional 0.8, integral 1.0, and we're leaving the derivative term small. So let's go back out to our telemetry screen, and we're locked. Let's try moving the speed. And you can see that while it's not oscillating, it is a bit underdamped. It settles rather quickly, but you can see some fairly crazy gyrations in the throttle. So this is a case where I think we've got still got our proportional gain a little bit too high. One last thought on the tuning: you might want to enlist a suitably skilled spotter to help you as you make changes like this. Your response, your setup will be a little bit different every time. You'll need to tune these parameters differently, but you can watch how the proportional, integral, and derivative terms vary. The proportional responds to an instantaneous difference. The integral drives the error signal to zero over time, and the derivative can provide some damping. But in a feedback loop like this one, the derivative has a fairly small effect unless you turn it up too large. And then the last point I want to mention is you've noticed that a lot of the state changes on the auto throttle get a pop-up message on the screen. Again, that's not so much for the pilot, but those pop-up messages, those system messages, also get stuck into the log file. Also put into the log file are these values of PI and DIC on the screen. They're in there as CTU propo, CTO integ, and CTU deriv. And so if you want to actually look at your log files, you'll actually see the points where your auto throttle was enabled and disabled, and you'll be able to actually look at the three terms that are being graphed as bars along the bottom of the screen. Once again, can help you with tuning your PID setup.